Section 7.2, Sum and Difference Identities. In this section, you will use the sum and difference formulas for sine, cosine, and tangent. Use the sum and difference formulas to verify identities. Now, using the sum and difference formulas, you'll be learning several new identities for adding and subtracting angles inside trig functions. Let's start with the sum and difference formulas for cosine. And that is cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And if it's cosine alpha minus beta, it is cosine alpha cosine beta plus sine alpha sine beta. So the way I remember this, memorize this, cosine alpha plus beta is cos cos minus sin sin, and then cosine of alpha minus beta is cos cos plus sin sin. And then next one is for sine, sum and difference formulas for sine. So that is sine alpha plus beta is sine cosine plus cosine sine. And sine alpha minus beta is sine alpha cosine beta minus cosine alpha minus times sine beta. And the last one, sum and difference for tangent. And we have this tangent of alpha plus beta is equal to tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. And same thing with tangent of alpha minus beta is tangent alpha minus tangent beta all over 1 plus tangent alpha tangent beta. Okay, so again, take a look at all these sum and difference formulas for cosine, sine, and tangent, and make sure that you are familiar with this, and use that to answer the next examples. Like example number 1, use a difference formula and to find the exact value of cosine 5 pi over 4 minus pi over 6. So we're going to use the difference formulas for cosine. So remember, this is the formula. So this is like your alpha, and this is like your beta. So your alpha, think about that your alpha is 5 pi over 4 and your beta is pi over 6. And remember, again, I'm going to rewrite it here. Cosine of alpha, the difference formula for cosine is cosine plus sine alpha sine beta. So let's do that. So that is equal to cosine of 5 pi over 4 times cosine of pi over 6 plus sine of 5 pi over 4 and sine of pi over 6. Cosine of 5 pi over 4 is negative square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2 plus sine of 5 pi over 4 is negative square root of 2 over 2, and sine of pi over 6 is 1/2. And then all we have to do is simplify this. Negative 2 times negative square root of 2 times square root of 3 is equal to negative square root of 6. 2 times 2 is 4. Negative square root of 2 times 1 is negative square root of 2, and 2 times 2 is 4. And to simplify this, so negative square root of 6 minus square root of 2 all over 4. And this is the answer. Okay. Number 2, use the sum formula to find the exact value of cosine 75 degrees. So since we know the values in quadrant 1, like pi over 6, pi over 4, and pi over 3, 30 degrees, 45 degrees, and 90 and 60 degrees, so we can rewrite cosine of 75 degrees as, in terms of, take note of this, in terms of 30, 45, and 60 degrees. Okay, so cosine of 75 degrees is the same thing as 30 plus 45 degrees, right? So now this is your alpha and this is your beta. So some formulas for cosine, that is, this is equal to cosine of alpha 30 degrees, cosine of beta 45 degrees, minus sine 30 degrees times sine of 45 degrees. And cosine of 30 degrees is square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. Sine of 30 is 1/2. And sine of 45 is square root of 2 over 2. And let's simplify. Square root of 3 over square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. 1 times square root of 2 is square root of 2. And 2 times 2 is 4. And we can rewrite this as square root of 6 minus square root of 2 over 4. And this is the answer. Okay. Next example. Use the difference formula to find the exact value of sine 105 degrees. So now, what's the easiest way to have two angles? So remember, from unit circle, we had the first quadrant 30, 45, 60, and then 90, and the second quadrant 120, 135, 150, up to 180. So 105, so think about that. You can rewrite this as, what do you think? Sine of 135 degrees minus 30 degrees. So you can use this too. Okay, and just to recall, that is sine alpha. So this is your alpha, this is your beta. So that is sine alpha cosine beta minus cosine alpha times sine beta. Okay, so now that is equal to sine of 135 degrees times cosine of 30 degrees minus cosine of 135 times sine of 30 degrees. Sine of 135 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Minus cosine of 135 is negative square root of 2 over 2. And sine of 30 is 1/2. So let's multiply this again. Square root of 2 times square root of 3 is square root of 6 over 4 minus negative negative, that's positive, so square root of 2 over 4. So this is now equal to square root of 6 plus square root of 2 over 4. Okay. Next, example number 4. Find the exact value of tangent 5 pi over 2. So 5 pi over 12, how are we going to rewrite that? So here we know that 5 pi over 12 is like 5 is 3 and 2. So 3 pi over 12 plus 2 pi over 12 is 3 plus 2 is 5 pi over 12. And 3 over 12 is 1/4. So that is pi over 4. And 2 over 12 is pi over 6. So we are going to use this. So meaning this is equal to 5 pi over 12. So we can rewrite tangent of 5 pi over 12 is equal to tangent of pi over 4 plus pi over 6. Okay. And recall the formula for tangent. That is tangent, right here, tangent of alpha plus tangent of beta is equal to 1 minus tangent alpha tangent beta. So this is your alpha pi over 4 and this is your beta pi over 6. So that is equal to tangent pi over 4 plus tangent pi over 6 over 1 minus tangent pi over 4 times tangent pi over 6. Now what is tangent pi over 4 is equal to 1. Tangent of pi over 6, the coordinates of pi over 6, sine over cosine. So that is equal to square root of 3 over 3 all over 1 minus tangent of pi over 4 is 1 times, again, tangent of pi over 6 is square root of 3 over 3. Then we simplify this. 1 plus square root of 3 over 3 is 3 plus square root of 3 over 3 all over, simplify this, 3 times 1 is 3 minus square root of 3 over 3. So when we cancel this, sorry, I'm gonna continue it here. So that becomes 3 plus square root of 3 over 3 minus square root of 3. And if I want to rationalize the denominator, so I'm going to multiply this by 3 plus square root of 3 over 3 plus square root of 3. And that is now equal to 3 times 3 is 9. 3 times square root of 3 is 3 square root of 3. Another 3 square root of 3. And square root of 3 times square root of 3 is square root of 3. All over 3 times 3 is 9. Minus square root of 3 times square root of 3 is 3. So that is 9 plus 3 is 12, plus 3 plus 3 is 6, square root of 3 over 6. And now let's simplify. 12 divided by 6 is 2, 6 divided by 6 is 1, so this is square root of 3. So this is the answer. Okay. Next one. Let's verify the identity sine alpha plus beta plus sine alpha minus beta is equal to 2 sine alpha cosine beta. So remember, when you verify an identity, you can choose the left hand side to simplify so that it is equal to the right hand side. So the first one, sine alpha plus beta, we know that that is sine alpha cosine beta plus cosine alpha plus times cosine beta. Sine beta plus this part here, sine of alpha minus beta is sine of alpha cosine of beta minus cosine alpha and sine beta. And based on this, we can cancel these two, cosine alpha sine beta, and now sine alpha cosine beta, if we add this two, is equal to 2 sine of alpha and cosine of beta. And this is exactly the same thing as the right hand side. Okay, alright, and now let's work on some lecture questions. The first problem, find the exact value by using either the sum or difference identity. So let's start with letter A, cosine of 7 pi over 12. So for letter A, we can rewrite this as cosine 7 pi over 12, that is 7 is 4 plus 3, so 4 pi over 12 plus 3 pi over 12, and that is 4 pi over 12 is pi over 3 plus pi over 4. So now this is your alpha and this is your beta. So now we can rewrite this as cosine. So that is cosine of pi over 3 cosine of pi over 4 minus sine of pi over 3 and sine of pi over 4. And cosine of pi over 3 is 1/2. Cosine of pi over 4 square root of 2 over 2 minus sine of pi over 3 is square root of 3 over 2. Sine of pi over 4 is square root of 2 over 2. So this is square root of 3 over 4 minus square root of 6 over 4. So that's why the answer is square root of, this is 2. Square root of 2 minus square root of 6 over 4. Okay. Letter B. Tangent of negative pi over 12. So think how to rewrite this. You can rewrite this as tangent of, to get negative 1, 3 minus 4. Right? 3 minus 4 is negative 1 pi over 12. So 3 over 12 is pi over 4, and 4 pi over 12 is pi over 3. Yes. And now this is your alpha and this is your beta. So using the formula, it's going to be equal to tangent of pi over 4 minus tangent of pi over 3 over 1 plus tangent of pi over 4 times tangent of pi over 3. And what is tangent of pi over 4? That is equal to 1. And tangent of pi over 3 is square root of 3. So 1 plus 1 times square root of 3 is equal to 1 minus square root of 3 over 1 plus square root of 3. Okay, that is enough. I will accept this. But if you want to continue this, you can multiply this by the conjugate. That is 1 plus square root of 3 over 1 plus square root of 3. Okay? And you can continue that. But again, I will accept this. 1 minus square root of 3 over 1 plus square root of 3. Last problem. Use the sum and difference identities to verify the given identity. So cosine x plus y times cosine x minus y is equal to cosine squared x minus sine squared x. So here we're going to use the left hand side and use the sum and difference formulas for cosine, since that is the left side. So cosine x plus y, that is cosine x times cosine y minus sine x sine y. That's the first one. Then cosine x minus y is cosine x cosine y plus sine x sine y. Then let's multiply this. So it's a long one, sorry. So if you multiply these two terms here, that's going to be cosine squared x cosine squared y. If you multiply this and this, it's going to be plus cosine x cosine y sine x sine y. If you multiply these two, that's going to be cosine x cosine y sine x sine y. Then multiply the last two terms, it's going to be minus sine squared x sine squared y. And simplify this. Cosine x cosine y sine x sine y minus cosine x cosine y sine x sine y, that is 0. So what do we have here? Cosine squared x cosine squared y minus sine squared x sine squared y. And remember, we want to verify this, that it is equal to the right side. So here, cosine squared using the Pythagorean identity is the same thing as 1 minus sine squared of y minus sine squared x, we know that this is 1 minus cosine squared of x sine squared y. Then distribute cosine squared of x minus cosine squared x sine squared of y minus distribute this sine squared y plus cosine squared of x sine squared of y, and simplify. So negative cosine squared x sine squared y plus cosine squared x sine squared y is 0. So now what do we have here? Is equal to cosine squared of x minus sine squared of y. And look at that. That is exactly the same thing as the right hand side. Okay, and that's it. This is section 7.2, and if you have any questions, let me know. Thank you.